information extract. Actually, I synthesized the maintenance of deep learning systems that are the first is called generative deep learning. Is a kind of algorithm dedicated to extract high order correlation, or taking into account the Professor Pardasani lesson. This is the problem to find concept, to analyze the logical, the meaning of the that is embedded in the data that you are analyzing. This information is suitable for pattern analysis or to obtain distributional property of the data that is embedded in the data architecture. This information is suitable for pattern analysis or to obtain distributional property of the data. Partition the data is embedded in the data software. This information is suitable for pattern analysis or to obtain distributional property of the data. Partition the data is embedded in the data software. This information is suitable for pattern analysis or to obtain distributional property of the data. an error could not be an error, could be an exception to a rule. This depends on what kind of knowledge do you have. The knowledge is the information, the meaning that is available about one object. There are three levels of knowledge. The first is the explicit knowledge. The explicit knowledge is the information. When I said, for instance, the DNA is macromolecules, I can communicate this information. And this information can be easily coded in a machine-readable way. In the same way, the results of a microarray is explicit knowledge, because there are the data. Then you can code this data, and you can use this data without any problem. It can be generally coded in a textual or numeric form or symbolic form. Is the general form of data. Strings, number, structure, what you want, image, and so on. Implicit knowledge is derived from the explicit knowledge, and it's derived by application of explicit knowledge. Roughly speaking, the implicit knowledge cannot be represented by a variable, but this is embedded. If, for instance, if I record, if I give an experiment, the result of PCR. The result of PCR, for instance, obtain a specific value. But there are other parameters. For instance, the temperature in which the experiment has been carried out, the ionic strength of the medium. What do you want? Microarray, the same. The experimental condition, i.e., the number that you can see include several variables that are not coded. Then, when you can have the results of your prediction, you have the prediction of explicit knowledge. You must, in the terms of data warehousing, it's important. The implicit knowledge, having information about it, is important to control the quality of data, or to control the homogeneity of data, the type of chip, the temperature, the condition, the cell lines. The cell lines is explicit, but the condition in which the cell line was grown, no. The third is the tacit knowledge. It's the experience derived by individual experience. The more simple example is the cooking. How many, the recipe of Indian recipe is changed by family. And the recipe passed from a generation to another only by the experience of your grandmother and so on. In a science point of view, scientific point of view, in some way is the experience of the operator. If you learn to use an instrument, there is an expert that teaches to you how to use. Then normally this tutor has a great experience in this instrument, and transfer to you his knowledge. But this knowledge cannot be coded. Essentially, these two types of knowledge are are not easy to be coded or to extract from machine learning. Or knowledge is correct, thanks. Okay, you have simplified the previous slide in this way. If the knowledge is communicable, or if the knowledge can be coded, can be put into your data set for train, or not communicable, then it is split into technical, because I do not communicate, for instance, how an instrument works, or cognitive because depends by the capability to acquire the information and put this information in the is used, is transparent, is a ghost information. Okay, you can see that logical relation CE and BC, in a general sense you can see that this relation DB and DA show the transitive property from one relation to the other, or from one concept to the other. In the circle, in the ellipses, the other is other available knowledge. The relation are the basic elements, the true and validated elements for data mining. The other is available knowledge that can be also used, but outside the ellipses, the unavailable knowledge. For the same object, we cannot use all the information that is available. In this case, is the problem to data source integration, or for instance, web mining system, or using different different paths that are not the normal databases. These things. We can come back to the data that one can use can be structured. The structured record is SQL form that is well known, or other form to organize the knowledge according into the database in a standard format according the need of according the necessity of the task. Semi-structured, they are not organized in data repository, but they contain data that allow to make a reference with the basic data, with primary data. And unstructured data are information that cannot be fitted in a specific data model. For instance, a text cannot be fitted in a model. You can say, okay, but PubMed is a database. PubMed is a database, but the text of the abstract in the database are not structured, are not fitted to the model of the. It's a field of a structural record, but the text is not structured. It is not cannot fit to any structure. It's not possible, because if I have a set of experiment, I said experiment 1, variable 1, 2, 3, and name and notation what you want. But a text you cannot split almost. I cannot split in different. This text I cannot split into different fields of the database. It's all the text is a feature. Okay, it is an element of the record. Thanks. Okay, this is my fil rouge that connects the lessons. If we can skip it directly, because in any case, recall the other lesson, please. And okay, sorry, come back one. As I attempted to split the EXPOSOME problem into into 5 different subfields in order to check to highlight the differences and the problem that we have for each subfield. Obviously, we're talking socioeconomic data, epidemiological data that someone this morning have talked with me, or environmental data, climatological data. My feeling is that, for instance, socioeconomic data, taking into account the knowledge discovery, is more complex because the tacit knowledge or implicit knowledge in this kind of data is quite high. Also in epidemiology, or also because sometimes some option was not directly coded into the report or into the database. Then the statistic protocol are standards, but what is the quality of the team, or what is the performance, or what is the time, or for instance, only the statistical criteria for critical region definition, for acceptance and other as being must be not communicated, not always communicated. Statistics, yes, because we must give this kind of information, but other situation not. For instance, in the collection of data about interview, how to manage it, or how to organize into classes the interviews. I decided for classes, no bad, intermediate, good, very good, or 10 classes. You have the results, you have the survey, but you cannot have information, too much information about the structure. The environmental data are experimental and more or less weak, are quantitative. The problem is that if the information is measurable or not. This is the, please. Okay, you can see here an attempt to give you some possible application of machine learning and deep learning in each subset of the exposome process. The chemical anomaly, landslide susceptibility, in this case you can predict, you can develop some knowledge discovery, because the data allows to, the events, geological data allows to attempt rule generation. The same also for climatological, because we have standardized data about meteorology and other things, fluid, thunderstorm, what you want. Molecular biology is well known. In any case, gene expression, protein structure, protein ligand interaction, regulatory domain, relation between proteome and disease, and what you want. There are a huge amount of the papers that work on it. Clinical is the same, but clinical, as I said, is affected in some way by implicit knowledge, because the diagnosis is normally, in some cases, not only obtained by lab screening, but also with the writing of the clinicians. Then there is not a standardization of how to write it. Now there is a international consortium, HL7, that push toward the standardization at the international level of health record. Otherwise, we remain with different linguistic difference that different doctors have. The last point is interesting because it's the drug repositioning. But the drug repositioning derived by the cost to develop a specific drug for a specific disease, for a specific target. If the compound fails to have a pharmacological activity on the established target, it's possible to put the same compounds in a pipeline to find alternative target, alternative pharmacological target. This is, roughly speaking, the drug reposition. In this case, one can also predict what are other possible targets. Why? Because the data are measurable. There is the data are coming from experiment in which the big problem, one of the error factor is the quality of the screening, or is strongly related to experimental activity. The last, social behavior, the demography. Now there are studies that use machine learning to predict the violence, to predict if someone make more than one crimes, the violence in many different social way, performance of the students, and now also the Brexit process has been submitted to prediction systems, and the political sentiment analysis, as you can see, I collect the interview and I decide what is the political trend, the political mood in a specific before a voting day or other. As you can see, in this case, it is completely text knowledge, because I can say a thing and then vote another thing. Okay, data. Okay, now the structural machine learning. The previous part described more in fast way the tools, but they can be used in different way. The first way is the data fusion. The data fusion is the process of parameter estimate from data originated by multiple sources. For instance, we have a different sensor at the environmental level, water, air, other. I can, on a specific area, I can monitor in a specific time using all the sensors simultaneously, and I can record the data from each sensor. Now, what is the problem? The problem is to find the statistical relation about the data coming from different methods, different sensors. The data fusion is the possibility to make statistical inference from different data sources. The basic approach that are embedded in data fusion are data association, is to extract the relation about the input data sources. The state estimation, for instance, the example is the position of an airplane, but otherwise in environmental point of view is the point estimate of pollutional level, and the prediction is found on the, and the state estimation is in fact the predictive system. This is the machine learning. The third, the decision fusion. Normally this system offers to the operator a set of alternatives, and the decisional part, the rules, and then obtained by the second step has been broadcasted to the user, and the user select what, according to his experience, what is the better action to activate. Thanks. Some application of data flow you can see here: analysis of data, capture environmental sensor, protein structure prediction, because in this case we have different, we assembled the output from high throughput crystallography. High throughput crystallography is an approach that allows to obtain a crystallographic structure using droplets of crystals. Then after you can assemble an high-order structure. It's a very expensive system. I guess there are only 2 or 3 centers. One is in the UK that use this approach, because as you can imagine, having a crystallographer that can work on a chip is very, very expensive. Disease prediction, in fact, because of disease prediction, having several sources that can be obtained from epidemiological database, clinical database, or what you want. The urban planning, why I put urban planning? Because in terms of exposome, urban environment tends to become more important. The expansion of many towns in India, China, create a specific environmental context in urbans. And the last, disease and pollution. This is you can find in the paper, and they use different approach to, for instance, there are some studies that link the air pollution and tuberculosis, and incidence on tuberculosis, because the pollution has an impact on immunological systems and increase the susceptibilities to some infectious disease such as tuberculosis. Thanks. Okay, this is an example from this paper that show you in which way the data fusion has operated into biomedical context. You can see, we come back, it's a strange data fusion because SIMP is a network in this case, and the things are strongly related, and the arcs connect the relation, as in the case yesterday about the ontology. Also here I do not know the meaning of I guess it's the length of the arc or the correlation between the nodes, and it was interesting because it's not a modular and parallel integration, but it's a network integration. The main feature of this figure is that for exposome we need a network integration, or in other way, a graph integrations. Then you can see the difference. It's interesting to note that disease is connected with ontology, okay, and with genes through the dotted line, and how the different different databases and different data are managed and analyzed depends by the tools that are embedded in the systems. I'm sorry, but I am using he only to give an idea of biomedical information there. I do not know if they use machine learning or if they use the statistics or what they have. You can find the paper on bioinformatics 2 years ago, and in any case we can please. Okay, and now we come back on the basis of the process. The problem is how to find the concept, or how to find the meaning of specific object. It's very complicated, because an abstract concept requires the convergence of syntactic logic and mathematics on the same board. And this is an abstract concept. The methodological approach for required to extract the basic knowledge to required for the concept formation is information retrieval for the methodological approach, data acquisition, data analysis, concept extraction, hypothesis generation, and theory formulation. That is machine learning, in fact. On the other side, observational approach, this can be automated. The observational approach are the measure, the recognition, and the experiment, and this define the concrete concept. what the experience of a scientist or us formulate, because here we can have physical data, the capability to recognize some results by expertise, experimental, and interpretation. This interpretation in this case is not automatic. Is what, in the diagnostic point of view, we have all the data, but the last decision is the clinicians. In the case of exposome, the interpretation, the decision is having all the possible information mined in the best way, is given to the political level or to the technical manager that must decide an action for a specific situation. Then the problem is the logic and mathematics that and syntactic, that is linguistic in some way, that must cooperate in the same to formalize the concept. As I said, the DNA is the basic molecule, is the genetic information element. It's clear, it's a concept, roughly speaking, but it's a written concept. Is a communicable concept. For a machine, for a computer, I must to formalize in which way I can represent this concept. A first logic order or other systems are built, and I must to have formal methods from logic and mathematics to code the concept in a way that the machine can read and can process or can create. This professor that now has died is Joseph Gauguin, is mathematics and logics, that attempted to fuse together different elements that are required for concept formations. The database semantics, as you can imagine, is the semantic level of data mining. This conceptual space is a geometrical representation of that knowledge on a hyperspace. The formal concept analysis is roughly speaking, is the coding of a concept in string with logical formalism or logical operators in order that can be represented. Information flow is in fact the element that bring new elements for concept elimination to generate a concept. And information flow workflow is, let me say, is the content in which the assistant addressed to generate concept is working. The concept is a very complex complex problem. Please, thanks. Okay, the problem is the concept required to way to is possible to organize the basic knowledge into categories. The categorization can be done is a process in which the objects are recognized as a group and understood, conceptualized. Then the groups that you obtain from a machine learning supervised or not represent contains a prototype of the concept and its variations. In the supervised, the rule abstraction from labeled samples, that is classical supervised systems. I can classify with a neural network because I have a good training set. I have trained my system with the training set and check, and the network has, in a statistical way, mapped the logical conjunction, logical links between the elements of my data. Then the classification class A, class B is related to the knowledge fragment and the concepts that are stored in a transparent way in the network. The other is unsupervised. Rule abstraction is performed by analyzing the unlabeled data and finding the hidden relation inside the data. The first, the supervised, as you can imagine, is more easy to use and more easy to visualize and to apply. The second, believe me, to extract that knowledge from an unsupervised system and to visualize it is quite difficult because it requires an additional statistical post-processing to analyze the degree of dependency among the features that we have analyzed. Thanks. Okay, this is the language. There is the concepts are related to the semantics. Don't forget the concept of semantic web and semantic analysis, because I would like to focus on this aspect, because EXPOSOME is not only microarray. Is unfortunately that not all the data are value from experimental data. Depends by a lot of additional situations, such as the language that is extensional semantics that describe the word, the language, the truth of the language allows to find the possible word, and there is intentional semantics, is the strength of the concept. At the end, language and conceptual structure, the cognitive semantic, combine the language and the conceptual structure. In terms of EXPOSOME, what is the meaning? The meaning of this slide said that we have unstructured information that give us information about pollution on a specific area. Description given by report, by census, but what you want. In this case, the language describe a word. Even if you have table data that are supplementary data, but it's the description that give to you what is the situation. If I say there is too much cadmium in the water and give you after the table of my experiment, I can use the experiment for creating a training set. But it's the text of the paper and the text of the report that give the meaning of or the relevance of the thing. How many, when you search a paper for an experiment for what you want, you read the abstract. The abstract is the meaning of the not always the results agree with the abstract, but essentially is the language that describe in this case the word of this experiment, the word of this case. If obviously if the language is true, if you find that correspond the abstract with the content, you can go to evaluate how strong is the concept. For instance, BCR2 is a gene involved in breast cancer. It's true, the literature confirm, and you can analyze the strength and how this semantic structure is strength, and how many variations they can take. The last is the complete system, cognitive semantics, that in other words is the aim of artificial intelligence. You can see here more or less what artificial intelligence wants to. Please. Okay, what is a concept? Concept is an abstraction or a mental symbol. A concept is the top level of knowledge discovery. Typically associated with a corresponding representation in a language. Then it's not a set of objects of a category, class, and their relationship. There is feature, and this feature must be correlated by logical operator and or not what you want. Or types of concepts are objective concepts that represent the real context in which the observer operates. In which that obviously I am here the concept of computer is quite clear in this context, or the concept of cancer is clear in a biomedical field and other. Subjective concept that represent a logical structure elaborated by the observer. Well, what happens? I am an observer. I make my experiments. I formulate my hypothesis. I produce a paper according to my hypothesis. It's not true. My paper is published, but this hypothesis is not only my hypothesis. It's not confirmed at the moment by other people. Then I publish only my hypothesis. Otherwise, that I do not know. Imagine what you want. What experiment do you want? There are the objective is the smoke originate cancer. Okay, but if I publish a paper, the smoke does not originate cancer. It's my hypothesis, but probably. Is mistaken. What is the effect? The effect that on the machine learning is that how many subject, what is the fraction of objective concept, let me say that is the good part of the training set, and what is the fraction of the subjective concept, or that could be a noise factor in the creating your data set, because I select all cancer. Talking about the smoke, I create a data set of 1,000 paper, 1,000 experiments about the smoke. There is also 20 experiments that does demonstrate that the smoke is not a factor of cancer, is not a cause of cancer. The 20 experiments in your data set have a weight, more or less 20%. This happens another way, and how to control your data set and how you optimize the fraction of good and bad data for the training. Because in this case, we can have a small bias due to subjective concept on the training, and then after on the final performance of your systems. The concept has some property that are called extent. Is the set of objects that belonging to the concept. The objects are the element that or the features at low level that originate the concept, that part of the concept, and intent is defined by the set of attributes sharing among the object belonging the concept. Then, this is important in terms of machine learning because these are the features that used to discriminate one class to another. And this is when you use classifier, you can find the different level of the different weight of each feature used for classification. You could working on this level. When you classify, when you prepare, and when you train a machine learning system, you use the extent, because the object on each class, on each group. When you want to decide what are the feature, the more relevant feature, you use the intent of the concept. Okay, the one way that I like very much is called conceptual clustering. It's a variant of conceptual clustering using symbolic data, more or less. Instead, then it is able to classify, to organize into groups different objects, not as new number, but as entity, as strings, as record, as what you want. And supervised concept learning, generating hierarchies to explain the data, is the property to establish a first row level of semantics. Row. So I would like to underline row. The application is the hypothesis generation and testing, the prediction based on group, and finding taxonomy. Why I'm talking about this thing? Because I am using similar approach to check the congruency of families of phylogenetic trees. It's also interesting for machine learning because in the phase of data cleaning, of data warehousing, having a possibility to filter out, to have a little initial level of semantic is not so bad. It can be useful for refining the other tools that can be applied subsequently. Technology discovery can be performed by a top-down, and we come back to the ontology. You here understand that one of the key points is the ontology, in which human expertise formalize the knowledge, and the other is bottom-up, that is starting from unlabeled information to knowledge creation, and creation this conceptual space. Conceptual space is represented as vectors in a Euclidean space, and you can go on, please. And the representation in this case is in a vectorial form that this approach allows to us to transform data in a machine-readable way, quality dimension feature. A conceptual space structure can investigate a sub-symbolic level. Then it's possible to apply deep learning, neural network, what you want to this representation. A conceptual space is a convex region space, is determined by Voronoi tessellation, and the structure of conceptual space is an emergent property. It's important because the structure of conceptual space as emergent property suggests the idea that the knowledge is a dynamic process controlled by dynamical systems. Thanks. Then the change, the concept drift. But a concept not always stable. A concept can change with the time. And changing with the time can change the quality of the data that we must to have used in an exposome analysis. 10 years ago, the impact of something on the glyphosate, okay, are used by 20 years, but only now emerged glyphosate problems. Why? This emerged, the concept glyphosate is toxic. 20 years ago, you can not create this kind of concept. Now, yes, the concept drift is a definition of machine learning that define how the statistical process of a concept change during the time. Change when, if you make a training set now in the 1982 on the same thing, the performance, and now make a training set now on the same topic, probably I'm using the same classifier, the classifier change the performance. This change of performance, if all the computational procedures maintained, could be, and if the feature, obviously, we create two data sets with the same feature, obviously, and the difference could be related to a change of relevance of some element, and then relevance of the concept. We can have changes in distribution of statistical property of the data, changes in the hidden context, implicit and tacit knowledge, changes in the user concept relevance. Glyphosate 20 years ago was irrelevant, now is relevant. Two types of concept drift can be sudden because probably the knowledge disappears and the relevance is dramatically changing in few time. Or for instance, or there was no information, immediately a lot of information emerged. For instance, microRNA. For a year there was no information about microRNA. In 2 years the number of publications and papers increased too much. Then this suggests a sudden change in the knowledge about this topic. The gradual drift, because a subject probably decreases the relevance with the time. Some topics in molecular biology and everywhere have a life cycle, then after tends to decrease. For instance, some techniques was used for 20 years ago, was widely used, and now has been restricted. Microarray was not used 20, 30 years ago, and now are widely used. This is a gradual decay of interest, and the gradual increase of interest in the case of some techniques, some knowledge. Please. I guess to have finished my talk, I would like to show you the references that represents, let me say, more or less the history of machine learning and deep learning and concept formation for exposome analysis. The first book is the PDP group, the Rumeland McClellan, was published in the 1986. I would like to underline that Joshua Benjo, that published a book on deep learning in 2016, was a member of those groups. And John Outfield and Greg Hinton, that works in the Toronto University, the father of autoencoder, is all that has published with Joshua Benjo a paper on nature on deep learning. It's the first paper that talking about deep learning, I guess, 2 years ago. And both are working with the PDP group. The second reference is very interesting because was the first systematic approach to develop dynamical model for computational neuroscience. And from this, the adaptive resonance technique is a model recurrent that is very similar to the new deep learning model, but it was dedicated to the dynamic of the neurons, neuroscience dynamic, 30 years ago, more or less. Upfield and tanks that are, John Upfield is still working, 78 years, is a father won the auto association, binary auto association. It was one of the first unsupervised method. Is a binary network using spin-like model in binary way. The other references are related to some learning in presence of concept written hidden context that is suggested the role of implicit knowledge and the role of hidden knowledge in the discovery process, and mainly what is the impact on the data set preparation, because we do not forget that all these things must be formalized or collected in your database. This is only this approach are only to take into account some possible factor that can affect the creation of a specific database, and this factor can also impact the quality of your machine learning model, your discovery model. The other are more or less related to the conceptual clusterings that is published now. You can have the DOE if you need. And the last one is the book that I guess is one wonderful book, Peter Gardenforth's Conceptual Space, that is very, very interesting. It is a logic and philosopher and mathematicians, the Swedish, that are working on these things. I have used this approach, his approach for my unsupervised system to classify something related to the Alzheimer's disease and other. And in fact, the method seems very promising. Obviously, it need modification, it need improvement from formal mode, formal analysis and so on, but it's really interesting. Okay, I guess to finish my talk, and if you have some question, I am here. Thanks. I know that we passed from neural networks to deep learning to the concept, but we make a jump from sub-symbolic to AI. The second part, the part of concept, the part acquisition of the environment, independent by EXPOSOME application, is the basic of artificial intelligence. When one take the sentiment analysis, one here in the TV, the robot cry or other thing, or one smile or what you want, the problem is the AI. AI is not only a statistical point, it's a merged together statistical, neuroscience, biology, and logic, and also philosophy, because the problem of classification, of class formation, of concept formation, for many aspects, is more philosophical. But the logic must formalize some philosophical concept into mathematical formula that can be useful for programming without analyzing, without any information about the mechanism of knowledge acquisition by human brain or also it's not possible to improve the quality of a classifier because there are the limits in some way. I'm talking about I would like to focus on the problem of types of knowledge. You do not believe, but the spread of different approach of different philosophers, different results, in which way impact your life every way in that. Because I said, now the database offers an organization of the data, offer the possibility to download or to upload the data. However, they do not offer or low quality or offer very low level of control and quality of data. If you go on UniProt, you can check any protein that you want. UniProt will give you a list. But if you control the star near each entry, you can see that the number of yellow stars that is annotated and curated is very limited compared to the list. Many are translation from MBI, Tremblay. Okay, they are theoretical. Officially, there are theoretical proteins. Then, if you use this protein, or if you use this protein as target, or if you use this protein, theoretical protein for any purpose that you want, you must be cautious to use. You must check in which way, for instance, the nucleotide sequence has been obtained, because the problem the assembly, the problem of obtain a mRNA remain even if NGS or other a problem that have a lot of limitations. Then in my paper I cannot write how many limits that I have. And the results are statistically consistent with the descriptive statistics. For me, it's all. But I do not know if there are some problems during the experiment. It's the data quality. We come back. If you transform or if you take some experimental data from some database, environmental, what you want, pH, it's not important. There is not, for instance, information about the methodology. Okay, methods is a paragraph. Not always have all the protocol. If you go on natural protocol or other thing, you can find anything. But short journals such as Phelps, Letters or other, you are very, very short. Then the problem of what an author have hidden in his paper is a big problem. And then as cascade, the database acquire the data, put the link to this journal, and accept the submitted sequence. After 1 or 2 weeks, you then download the sequence, you make an alignment. After 1 year, you can go to the database, pick up the same set with another Tremblay proteins. You make another alignment, and the alignment is a little bit different. That's because someone has upgraded the sequence. the problem of tacit knowledge is in more formal way is this, because I must access to the record. I must to check how many times the entry has been modified or not. It's only, I would like to give you only idea what problem do you have to prepare your data set, any data set, from microarray to PCR, what you want. This is a cell that, okay. This is only a warning, okay? Thanks. It's complicated. No, this is when one uses this method. The more simple way is the statistical parts, because there are formula. But the common language among different words to say the same thing. Because if one scratch the surface, more or less, we're talking about the same thing. It's very complicated. It's very different language creates a problem to manage it. I hope to be quite clear, because the thing was very complicated. Would not overlap with the machine learning given from him. But in terms of exposome perspective, this is a big problem, because if I give you a good training set, you can be confident about your methods. But if I give you a bad, you are not sure. Then the problem is to be awareness about the possibility that there are problems, and what kind of problem.
यहाँ से चलाना है, वहाँ से चलाना है।
यहाँ से ऑपरेट करना है।
यहाँ से वहाँ से करना है, यहाँ से करना है। दोनों जगह करना है। नहीं, वो कहते हैं चलाना पड़ेगा, तब वो
This is the legend. The figure. Yes, it was. it's necessary to get the paper to understand if they explain this implicit knowledge.
हाँ